Thank you so much. It's a pleasure to be back at Angelbeat once more. My name's Mamoon Chowdhury. I'm a solution architect with AWS, and I'm joined by my colleague DJ Kulkarni. We are both solution architects that spend a great deal of our time every day talking with enterprises and customers like yourselves, specifically around how they can um, meet their business goals of elevating patient care, regardless of their particular sector of the healthcare industry. And we spend a lot of time helping them transform their businesses to take advantage of the cloud and artificial intelligence to really differentiate themselves within the industry. So it's a pleasure to be here with you today. If you'll excuse me, I'm just going to come off video just for the purpose of this presentation, but hopefully you can still remain to hear me okay. Today, we're going to be talking about how you can unlock your data to transform patient outcomes. Now, there's a lot there underneath that statement, and I'm going to spend the next, DJ and I are going to spend the next 45 minutes or so explaining this topic in greater detail. If you've seen any of our prior Angelbeat presentations before, this slide will probably look very familiar to you. It really kind of highlights the potential of generative AI across the patient journey. This is what DJ and I deal with on a day-to-day basis as we work with our customers. Um, Across the industry, we see daily enterprises that are trying to understand how they can use AI to optimize, for example, their clinical workflows. Things like summarizing notes from patient conversations, consolidating records from EHR systems, using AI to optimize medical imaging and diagnosis, managing patient care, reviewing patient care records, identifying risks to patient through all of the data that our customers have access to within their cloud footprints. Managing public health, providing patient engagement solutions, self-service triage, whether through a mobile application or a website, using AI so for patients to be able to kind of be involved in their healthcare journey on an automated basis, on an efficient basis, but also in a safe and a responsible manner as well. Having kind of proactive patient communication, we'll talk about that later on in our presentation, delivering post-discharge care guidance to patients as well. Essentially, all across the patient journey, we are finding that there's opportunities to use AI to really transform how care is given to the patient and ensuring better qualities of outcome, or sorry, better outcomes from those patient journeys as well. What we hear from customers very often is that the volume, variety, and complexity of their healthcare data is rapidly escalating. It's creating challenges in not just capturing that data, but storing that data, analyzing it. And keep in mind, there are many disparate data types that our customers have to deal with now. So it's really hard to optimize for cost efficiency when you're trying to ensure really quick, efficient data access. It really requires tailored storage. It requires an efficient way for you to kind of catalog your data for a single patient across many different data modalities. You may have genetic data, may have medical imaging data, you may have patient records, visit notes, insurance policy documentation, and so forth. We find that researchers, clinicians, biopharma professionals are increasingly needing to use and integrate these diverse types of data in concert with each other. And that further compounds the complexity of getting insights and driving impact out of the data that they already have. The problem necessarily isn't data acquisition. The problem is cataloging the data, being able to manage the data, being able to govern the data so that you can begin to get value out of that data that is meaningful and actually has an impactful and positive change on the patient's treatment journey. Um, just to give you an example, we often have customers who deal with clinical trial data, and you know if you're trying to decide whether to include candidates in a clinical trial, you may be looking at genetic biomarkers, you may be looking at family history, you may be looking at medical images. So all of these kinds of data need to be in one place and need to be accessible very easily, and they need to be consumed in a way that you can generate meaningful data-driven decisions through them. So really, to unlock healthcare data, organizations have to be able to handle different data types efficiently, but also master the art of managing and integrating multimodal data seamlessly across a variety of different use cases. Now, the Economic Forum issued a while back an analysis here, and what they found was that healthcare data is really kind of exploding. Hospitals annually generate about 50 petabytes of data. However, shockingly, what they also found was that 97% of that data goes unused. And it's largely due to storage and accessibility challenges, which is really the first step in kind of harnessing that data in a single place before you can even begin to consume it. Compounding the problem is that diverse nature of the healthcare data across many different modalities, many different formats. It's really hard to scale up storage, people tell us, before they come to the cloud to get really efficient data utilization out of all of these heterogeneous data types. So unlocking the full value of healthcare data really requires solutions that overcome the storage, the accessibility, and the data integration hurdles for you to be able to get meaningful insights that drive data-driven kind of healthcare transformation. Here's what DJ and I commonly hear from our customers on a daily basis. You may see some trends here. But in addition to the reality of so much data going unused, there are like really common themes that DJ and I hear in our conversations with healthcare and life science executives. They need to make, for example, drug discovery data driven and de-risk their research portfolios quicker and more efficiently. They need to improve the time they spend ingesting, acquiring, and processing data, just so they can get to the right place where they can begin to govern it, let alone actually act on it. And so there are various challenges. Another one is data quality as well, amongst the many different data providers and a fragmented data ecosystem. How do you manage that on top of data regulations that are varying globally? How do you manage that in a fast-paced environment when you've got all of these other complexities that you have to deal with? So as I mentioned, this is something that DJ and I help our customers do on a daily basis. And I'd like to take the next few minutes to talk about that in more detail. So at AWS, we try to help numerous customers across the industry really transform healthcare by giving our customer obsession across the entire care spectrum. We provide a trusted, compliant platform for healthcare, ensuring security, ensuring agility, scale, enabling innovation, but also understanding that it's a very highly regulated industry where compliance is key. Our certifications and our shared responsibility model enable organizations to really focus on what matters most, the patients. What we do is we help unlock the potential of healthcare data by enabling that secure, compliant, and scalable processing, storage of medical information, and that you can exchange it. We help with interoperability, and that really goes a long way to driving value-based care delivery. We work a lot with clinical organizations to help improve their operational excellence so they can really kind of transform data into strategic assets for things like population health management, disease forecasting, even back office functions like revenue cycle management, empowering healthcare initiatives with AI and machine learning. So Across the industry with AWS, healthcare organizations can really begin to harness their data and start accelerating innovation by using AWS and a thriving partner network to build or co-develop new products into the healthcare ecosystem that allows them to kind of stay at the head of the curve in improving patient outcomes. Data science and analytics, machine learning are really the cornerstone of a lot of the innovation we see today in modern healthcare and life sciences organizations. The ability to kind of discover, develop, and deliver new treatments, new devices as part of that patient care journey is really important. We provide that high quality technology backbone that kind of facilitates that entire patient care journey. Um, we meet stringent security and compliance regulations, enabling data access and serving as a trusted advisor to support the entire patient journey. So we work with um, uh, not just healthcare providers, but all of the independent software vendors that supply those healthcare providers as well. So you very often find healthcare AWS's healthcare AI built into those products and services that are used by healthcare providers. This really kind of empowers those organizations to shift the focus from maintenance, from just keeping the lights on, from just kind of trying to collect a subset of their total data footprint into a highly automated ecosystem where they're implementing artificial intelligence to deliver near real-time insights that improve patient outcomes and increase satisfaction for clinicians and patients alike. And this is really what we help our customers get to at the 100,000 foot level. This is what DJ and I do on a daily basis. We help those healthcare organizations by giving them the tools to collect, store, catalog, analyze, and act on their own data. What we find really, what our customers really value amongst a couple of key things is the ability to easily collect and ingest across a wide range of diverse data sources within their ecosystem, ensuring they have access to their clinicians have access to the most comprehensive and up-to-date kind of patient information, for example. We provide secure and scalable data storage solutions, which I go into in my next slide, with cataloging and advanced indexing that allows for really efficient data management to discoverability as well. Then we also bring AI and machine learning services into that now. So now healthcare organizations can derive actionable insights from their own data, enabling data-driven decision making and personalized care. Now, in this next slide, I'd love to show you what that looks like in a little bit more detail. So there's an awful lot going on this slide. So allow me to just take a second to kind of give you the lay of the land and walk you through what's going on here. This is really a high level view of what a lot of our customers do on a daily basis. On the left-hand side, they have many of those diverse data sources that I mentioned earlier. They may have their own EHR system like Epic or Cerner, for example. They may have genetic data. They may have medical imaging data, digital pathology data. They may have audio, clinical audio. They may have recordings from telehealth visits and many other diverse sources of third-party data. The very first step that we help our customers with is the ability to kind of store, query, and analyze that data as well. And I'll talk a bit about some of the components of that, um, some of the components that enable those foundational capabilities now. AWS Health Lake is a HIPAA eligible service that offers healthcare companies a view of individual and patient population health data using the FHIR standards, the FHIR API-based transactions to kind of securely store and transform their data into a queryable format at petabyte scale. This enables them to analyze their data using machine learning models to kind of ad hoc query their data on a patient by patient basis. So our customers use those APIs to easily import very large volumes of health data, including things like medical reports, patient notes from on-premise systems. It's really a secure, compliant pay-as-you-go service in the cloud. It offers natural language processing capabilities as well, so that customers could kind of understand and extract really meaningful medical information from a single copy of raw health data, such as medications or procedures or diagnoses. AWS Health Omics on the right-hand side of Health Lake is a multimodal kind of it allows you to store multimodal analytics across different data sources like DNA, RNA, and so forth. It allows organizations to store, query, and analyze that genomic data and other omic data, and then generate insights from that data as well. So using these services now, you can begin to combine your existing patient records, for example, from your EHR system, with the genetic information that you have about them as well. AWS Health Imaging is a storage service that allows builders like independent software vendors who supply healthcare providers the ability to develop cloud native medical imaging applications. AWS Health Imaging effectively ingests medical images in the DICOM format and provides APIs for really low latency retrieval. So it's really purpose-built storage for health imaging at petabyte scale. And finally, HealthScribe, which we'll talk about in more detail later on in this presentation. Um, excuse me. Automatically generates transcripts and summarized notes from patient clinical organizations. So that's the real middle layer. That's where we kind of store, query, and analyze the data that we have that our customers have available within their on-premises footprint, for example. To the right of that, you'll see the integration layer. Now that you've kind of been able to put your arms around this data, you're now in a position to be able to integrate it with downstream capabilities where you can begin to act on that data. So whether it's putting it into a cloud native petabyte scale data warehouse like Amazon Redshift, where you can integrate it with AWS Data Exchange, which is a secure way, think of it as a secure portal to manage third-party data access for interoperability. Maybe you have a research partner where you want to share anonymized data for them to be able to do research studies. You can use Data Exchange for them to kind of opt in and subscribe to those in a very secure and a compliant manner. So you can invite them to share data with you. The AWS Clean Rooms allows you to create copies of the data that are shared in a single location, where everything is tracked and audited. So in highly regulated and compliant situations, you can collaborate with external parties very, very easily, even when you're talking about very sensitive data that perhaps must be cleansed or must be secured in line with a number of different regulatory regimes. Clean Room supports that as well. Now let's talk about acting on that data. And that's where you see the right-hand side of this slide. Once you've got your data in a place where you can govern it, you can share it securely, you can integrate it with downstream systems, you can now use it to maybe build your own machine learning models, build your own predictive dashboards using Amazon QuickSight, which is a business intelligence tool. So this is where, for example, if you were doing population health reporting, if you were doing that kind of work, this is where you would come in and begin to derive actionable insights from your data. You can also use AI for clinical applications as well. So whether it's AI for processing medical images, genetic data, patient records, maybe it's a clinician-facing application, maybe it's a patient-facing chatbot, whatever the case may be. This is what you'd be able to do. And there's a whole host of use cases that this ACT layer enables. And we'll talk about those use cases in more detail. But under the hood, this is the 100,000-foot view of that footprint that I would encourage all of you to kind of think about. Maybe you have a portion of this in your organization already, but maybe this is an aspirational view for you. But this is what DJ and I do day in and day out, is we help customers align themselves with this vision. So they can produce not only just meaningful insights, but there's a lot of innovative and transformative applications and use cases that they can enable with a footprint like this. So it's incredibly open-ended, and we'll talk about that in more detail.
Hey, Mamoon,
Yes.
one question. I know that Robert, who obviously does a lot of work with major hospitals, and Robert, I'll let you chime in here. I'll just make sure I could unmute your microphone. He had questions about, some of the security controls as you're deploying solutions like Bedrock, and is the data SOC 2 compliant? And Robert, I don't know if there's anything else you want to add.
Yeah, so the other thing is, as you know, with HSS.gov reports that hospitals are being breached every day throughout the United States. I think this year there have been over 37 hospitals been breached.
Mhm.
So a lot of hospitals that I manage and help with their IT technology, they do not want to use anything that is dealing with AI until we have some regulatory compliance security controls in place. Some of the products that we wanted to use store the data in a third party, which is a violation of HIPAA. In addition to that, some of other applications are storing data and being accessed by foreign nationals, which is a violation of HIPAA. So geofencing for US citizens, it is one of my concerns. And also, I think AI is wonderful, but how do we protect patient data?
Yeah, so thank you for the question. There's an awful lot. I could probably spend a day answering your question.
Well, I have a day, so let's do it.
Yeah. So I can answer it in complete detail separately, but let me start by saying, first of all, that we have many healthcare organizations today across the industry that are securely and efficiently using AWS as a platform to do exactly what I'm describing there in a HIPAA eligible way. All of the services that I'm sharing with you here are HIPAA eligible. Security is really job zero at AWS, and we don't do anything unless we know that we have a good answer to the questions that you raise. So I'll make a couple of points for you that will help answer, I think, your question. The first of it is that we actually go a long way to reducing the compliance burden for our customers by giving you HIPAA eligible storage layers and compute layers and AI layers that you can fold into your architecture. The scope of responsibility that you have for ensuring HIPAA compliance decreases dramatically. You become responsible only for the applications and capabilities that you build on top of this infrastructure. So that's the first thing that I'll say. Secondly, everything in AWS is you have the ability to track, audit, control, and limit. So no data comes in and no data goes out of AWS without your explicit consent. We don't have access to your data unless you specifically grant us access to your data. We give you the tools to audit that, to manage that, to govern that, to encrypt your data at scale as well. We give you also many, many regions around the globe where you can put guardrails in place to control not only just who has access to that data and how they consume that data, but where that data actually resides. So if you have to reply with geo-specific or country-specific regulations around data residency, we give you the controls to manage that. So your data becomes locked down to that specific geographic region or country. So there's many, many different layers of controls guardrails, including evidentiary controls that you can turn around and give to an auditor to show that you're meeting your compliance burden. We serve not just many enterprises within the healthcare industry. We deal with many highly regulated industries, including governments and government agencies as well. And so our cloud supports many, many different security controls, compliance regimes. And the way I describe it is a rising tide lifts all boats, simply put. You get the benefit of all of that. And what we commonly hear from customers is they find it incredibly hard to meet the range of security controls, governance controls, auditing controls that they have in the AWS cloud. They find it incredibly hard to replicate that breadth and depth of governance maturity within their own data centers. And so for those enterprises that really kind of struggle with good governance of sensitive health information, with the good governance of AI in conjunction with that information, I would turn it around and say probably the easiest place for you to be right now is in the cloud. So on this theme, health systems around the world produce a massive amount of unstructured data on a daily basis. DJ and I see this very, very frequently. So we're talking things like clinical documents, scanned reports, forms, tables, medical literature, patient visit notes. However, much of this information really goes unused because it's unstructured. It's not necessarily in a database somewhere. And so extracting text and medical insights is a non-trivial problem for our customers. Amazon Textract is an AI service that automatically extracts text from documents like insurance claims or medical notes. What customers commonly do is they connect that in a pipeline with Amazon Comprehend Medical, other AI service, which looks at that extracted information and maps it to common medical ontologies like RxNorm or ICD-10. So, for example, if you were to feed into this a clinical note, for example, Amazon Comprehend will identify in that note what were the anatomical features that were mentioned? What was the PHI data? What do we know about the patient? What was that mentioned? What was mentioned there? What was the diagnosis that was mentioned? Were there any prescription medications mentioned in that report or those notes? And if so, what were they? Was there any dosage regimen that was mentioned? If so, what was that? So it maps it to common ontologies and extracts its structured information that you can now put perhaps into a database table, or maybe you can store it as part of the patient record, or maybe you may wish to do some population health analytics based on a subset of that data. That's entirely up to you. But the data that was locked away in that unstructured format, which would have required somebody to manually read that document and maybe create an entry in a database table somewhere, can now be automated using AI and Comprehend Medical. And the final step of that is storing that into Amazon Health Lake so it becomes part of the patient's medical history. This is something now that enterprises are commonly doing in healthcare on a daily basis. That they're chaining these AI services together to really take that unstructured data and get actionable insights out of that unstructured data. We're going to talk about one of the other ways in which our customers do that, and I'm going to hand over to DJ, who is going to talk to you about AWS Health Imaging. DJ, all yours.
Thank you, Mamoon. Great discussion up till now. So let's look at AWS Health Imaging, which brings incredible scale to DICOM imports and ingestion. It can easily handle the daily ingestion workloads for new procedures and do this even while ingesting multiple petabytes of data from another system. Scalable ingestion is not only important to support clinical workloads, but it also saves you money for key use cases such as PACS, migration and archival consolidation. Getting started with AWS Health Imaging is easy. You can start by bringing your DICOM images in an S3 bucket using one of the many S3 enabled products available from AWS and our partners as well. Next, you can evoke an API to import the DICOM data into AWS Health Imaging. AWS Health Imaging it reads the DICOM data from S3 bucket and optimizes for storage and fast access. Finally, your medical image data can be accessed with sub-second speeds from image viewing applications. From our ISV partners, you can use SageMaker, our leading AI/ML application, grant access to remote users using robust access control mechanisms. Like other AWS services, health imaging was designed to be building block for our builders. It allows developers to focus on delivering more high value functionality and spend less time on undifferentiated heavy lifting. Health imaging is workflow agnostic and can be used to build application in variety of industries, including clinical research, medical devices, and pharmacy. Finally, AWS Health Imaging is a DICOM compliant, so your data will remain interoperable with standards-based solution. Next slide, please. So we have customers today building applications for enterprise imaging such as PACS, specialty procedures, enterprise viewing, and patient viewing. For AI/ML use cases, customers are building solutions that will allow them to build cohorts over their entire archive in hours, something that currently takes them weeks for on-premises workloads. Customers are using AWS Health Imaging with SageMaker for training and inferencing, QuickSight for operational dashboarding, and Redshift for analytics. Other customers are starting with using AWS Health Imaging for long-term archivals, allowing them to reduce cost associated with their on-prem storage management. And customers can also combine clinical imaging with Omnics data and health records to deliver insights for precision medicine. So it's a multifold approach, and we are trying to solve a lot of challenges which are there in the industry today using health imaging. Next slide, Mamun. So let's look at some of the challenges. So protein engineers need to develop novel protein forms with desirable shapes and functions for potential drug candidates. The solution for this would be build a generative AI model called Chroma on AWS, capable of generating large protein complex that adhere to special biophysical constraint. The other challenge could be efficient, scalable, and automated way to run custom-built digital biomarkers, which are on-trial participants, wearable devices data from large global clinicals. The solution would be to leverage AWS to build a scalable, flexible, secure, and reproducible solution with a GXP compliant, serverless, event driven for parallel processing and automation with auto scaling, obviously. Other challenge which we saw was Merck Center for Outcomes and Research. So these are some of the customer examples in which we are seeing how the challenge of outcome research and evaluation required a cloud-based data and analytics platform to manage enterprise level use from a real world data perspective. So the solution what Merck used was adopt AWS services like data exchange, Redshift, along with some other platforms as foundation for real world data exchange. And then the next challenge was with Philips, where they developed a solution to help doctors deliver personalized care to cancer patient amid increased treatment options and desperate patient health data. So the solution they chose was to build a healthcare solution for on AWS that integrates desperate data to provide doctors with a complete actionable view of patient and aid in choosing the best treatment. So these customer examples illustrate how AWS empowers healthcare and life sciences organization to overcome data challenges, drive innovation, and ultimately deliver better outcomes for patients by unlocking the power of their data. Moving on to the next section, let's look how you could use AWS Health Scribe in AI generated clinical documentation. Next slide, Mamun. So the key thing here is the clinical documentation is a burden. For every hour spent with patient, clinicians are spending nearly twice as much time on administrative tasks like clinical documentation. This imbalance takes away precious time from the patient care overall, and nearly 60% of clinicians have reported feeling of burnout with excessive workloads. And the second most important point here is the impact of patient care and clinician well-being. The clinical documentation burden is not just about paperwork, but it's about people. It compromises the quality of patient care and contributes to clinical burnout. So professionals are uh, medical professionals are deeply committed to deliver the best possible care for their patients, but what we are seeing is 57% of the healthcare providers report excessive documentation is leading to clinical burnouts. 2 in 3 patients report that having bad patient experience is either a provider, hospital, or pharmacy with lack of empathy towards patient-provider interaction being the leading reason. So the key question we must ask ourselves: can we use technology efficiently and responsibly to mitigate some of these challenges? So as we consider to immense clinical documentation burnout and its impact on patient care and clinical well-being, we must ask ourselves, how can we use technology, especially generative AI, to address these challenges by exploring the responsible way of doing it and finding solution which would help with this growing challenge? So AWS introduced Health Scribe and HIPAA eligible service designed to empower healthcare software vendors by automatically generating transcript, summarized notes, and clinical insights from patient clinical conversation within their application. So, overcoming the limitations of traditional LLMs, traditional large language models face challenges in clinical note summarization. Limitations include, extensive training efforts, hallucination risk, inability to handle production scale workloads. The health scribe domain adapted approach, we leverage LLMs specially trained for accurate clinical insight, synthesis from medical conversations. And then the third point is production ready, compliant, and scalable. It's HIPAA eligible service for maintaining patient privacy and healthcare compliance, designed to process large volumes of clinical data while ensuring scalability. So, using AWS Health Scribe, it helps the software vendors to automatically generate, summarize, and give the clinical insights by analyzing the conversation. And Health Scribe integrates natural language processing with generative AI, specifically trained for healthcare industry. Um, Moving on to the next one, let's take a look on how this service works at a very high level. To start with, the clinician takes consent from the patient to record their conversation. The conversation is recorded in the clinical application, which can be through mobile apps, healthcare application, or a hardware device. The application sends the conversation audio to AWS Health Scribe, and Health Scribe processes the audio to produce transcript and clinical notes inside. Under the hood, Health Scribe leverages and optimizes various different AI services to deliver these results. For example, use the MET for transcribing medical speech to produce robust transcripts. The service is trained on far field audio, converting multiple accent collected from different hardware devices, even in noisy background. Health Scribe then leverages fine-tuned Bedrock LLMs using specified healthcare data for summarizing transcript and producing citations. The output from Health Scribe can then be used by healthcare software providers to share in a easily viewable clinical notes. So the core benefits is enhanced medical productivity with generative AI notes that are easy to reference, edit, and finalize. Reduce development time with unified conversation and generative AI services. So with that, I would like to showcase a demo of how a prototype which we built, how Health Scribe could be used in any of the clinical conversation, and how easy it will be for the clinicians and the providers to showcase that. So I'm going to, so if you are able to view my screen, here there is one of the conversation which was, it's a conversation between a clinician and a patient regarding their knee problem, which the patient visited the doctor, and using our Health Scribe, you can do this conversation gathering real time, or you can get the audio from the device as mentioned, and then it will analyze everything. Here, you can redirect all of the PII data between the clinician and the patient, or you can have specific PHI information redirected. So you can listen to this particular conversation.
So when you transcribe, are you able to tie it to a specific patient ID?
You can. So if you use it in your, like what our ISV vendors are doing it, they are tying it to their software for that particular medical profile for the patient, and only that particular profile to which the patient visits the doctor, you can pull up the transcript. This is just like a prototype of what's the art of possible and how easily it helps the clinicians to figure out what the problem was and get insightful notes, as you can see here, where it is talking about what's the patient details, what's the exact history, what were the past medication, what is the social history of that particular patient, and based on any physical examination, what the doctor did, what's the diagnostic test, what's the assessment, what's exact problem here. And it gives a complete summary, which can be later on viewed and used for analysis. Plus, there is also the audio here, which can be played back to actually listen, and where we say, human in the loop, to make sure that, okay, if there is any other thing which is not correctly captured, the particular clinician, doctor, provider can go back and listen to this whole transcript between the patient and the clinician to go over and discuss on that. So we just wanted to showcase how easily you could use this and how easy you can get the PHI information pulled out. You can also look at what was the small talk, where the silence was, and you can use it for your benefit to understand how much time a particular patient is taking to when he visits the clinician or the doctor, to finally come to understanding what exactly has happened. So from here, I would like to give back to Mamoon.
Great, thank you very much. In the interest of time, I'm going to pick up the pace a little bit. I just want to share with you one quick story here. So 3M is one of our enterprise customers. They use HealthScribe today. They're using it really as a foundation in their suite of offerings to offer HealthScribe to expedite, kind of refine and scale the delivery of their clinical documentation and virtual assistant solutions. So here's an example of generative AI being used in a highly regulated industry to really help address a tangible problem that we hear about on a daily basis. The message here really is this: if you can get your data, all the different kinds of data, into a place where you can manage it, where you can govern it securely and in a highly regulated way, there are many, many cool things that you can do with your data that are not just cool, but actually have meaningful outcomes that change positively parts of the patient care journey. And here's some examples of that. Our customers tell us they feel that they face many challenges and they must respond to many different industry trends. As you can see here, we showed you one solution that directly addresses one of those. Do any of these here sound familiar to you? We talked about combating clinician burnout, but one of the other things we commonly do is help our customers enhance patient patient experiences as well. So whether that's modernizing how you handle clinical information across your ecosystem, automating processes, automating workflows for seamless operations, implementing voice capabilities with your user interfaces. These are all things that we're doing in healthcare today. And another really, really important thing is a trend is facilitating that kind of interoperability and data integration between healthcare enterprises and their partners, commonly research partners, but also government agencies as well. How do you do that, but also meet regulatory requirements? How do you give clinicians access to kind of longitudinal patient records securely and quickly and efficiently, and in a way that they can really easily consume, no matter what format the original data was in? There's all kinds of different things that you can do when you bring these clinicians together. And here's some examples of what that could mean for patient care. One of the things we commonly hear about and we help customers with is what we call patient care nudges. Can you kind of proactively remind patients to take their medication, to schedule an appointment, to check in with them? Can you use AI to figure out the best format, the best channel, the best way to kind of really have an intimate kind of conversation and relationship with your patient, even if you've got 1,000 or 10,000 or 100,000 patients to manage? How do you still do that effectively? So that kind of proactive patient engagement using AI is something that we're seeing a lot of. Things like early disease detection, analyzing patient data to identify, potential risk factors, trying to drive earlier diagnoses and clinical interventions so you get improve outcomes, having data-driven mental health support, using data-driven mental health assessments, for example. These are all of the kinds of things that you can begin to consider. So I'd ask each one of you to consider what would be a really meaningful outcome for you. On the right-hand side of this slide, you'll see some examples of some of the things that you could accomplish today. These are the things that DJ and I work with enterprises across the healthcare ecosystem to do on a daily basis. Are any of these particularly meaningful to you? How would you prioritize these? The rest of the chart on the left-hand side of that right-hand column shows you all of the steps that you could take in AWS today to get to that meaningful outcome. And you'll see that. And you see that in the top left-hand corner. It starts with building what we call a lakehouse. Think of that single place, whether you're using health imaging, for example, to store medical data for your medical imaging data for your patients, building a cloud footprint that's secure, that meets your governance requirements. We give you all of the tools and capabilities to be able to do that. And then you can begin to fold in AI capabilities on top of that and other advanced analytics to be able to meet the outcomes that you desire on the right-hand side of this slide. So I would really encourage you to kind of work backwards from your desired outcome and engage with solution architects like myself and DJ, your AWS partners, to be able to kind of figure out how do you arrive at that outcome using the steps that we're showing here. I'm going to close here. I would encourage you to start your journey today. Consider the use cases that would be most transformative for you. Engage your AWS partners to conduct what we call a HCLS data maturity assessment to help kind of understand what is the lay of the land, what would it take to get you to one of those meaningful outcomes, and can we build a sequence of baby steps that are really kind of feasible for you, and help you get to that outcome that you're trying to arrive to. We have a program that I haven't touched on before called the Data Driven Everywhere program. We also have a Generative AI Innovation Center. Put simply, we are positioned to begin this conversation with you today and to enable you to get to that meaningful outcome that really kind of transforms the patient care journey across many of the ways that we described and many others that we haven't. So whatever it is that you think may be really interesting, may be a really cool aspirational goal for you and your organization, please do consider reaching out to us, because the odds are DJ and I have a lot of ideas, and our other colleagues around the globe have a lot of ideas around how you can achieve that meaningful outcome in your world. With that being said, thank you so much for your time and for your questions.